Paul Kozemchak stood in a Pentagon briefing room in August 1964, watching three-star generals dismiss his idea before he'd finished explaining it. The Air Force had lost another F-105 over North Vietnam the previous week, the fourth that month, and the brass wanted solutions that looked like solutions: bigger bombs, faster jets, more missiles. What they didn't want was a 38-year-old electrical engineer from Sylvania proposing that aircraft could jam enemy radars by carrying their own electronic countermeasures in external pods. The concept violated everything the Air Force believed about electronic warfare. Since World War II, jamming had been the domain of specialized aircraft, massive EB-66 destroyers, packed with equipment and operators, flying standoff orbits while strike packages penetrated enemy airspace. Kozemchak was suggesting that every fighter bomber could protect itself with a pod no bigger than a fuel tank, using deception techniques instead of brute force noise jamming. The generals saw an electronic salesman trying to shrink a Cadillac into a lunchbox. Kozemchak had spent 18 months studying the problem from Sylvania's Electronic Defense Laboratories in Mountain View, California. Soviet SA-2 guideline missiles were killing American pilots at an alarming rate, and the standoff jamming doctrine wasn't working. EB-66s couldn't escort strike packages into the heart of North Vietnam's defenses. Their jamming signatures told enemy radar operators exactly where to look, and SA-2 batteries simply waited for the strike aircraft to emerge from the electronic fog before launching. The loss rates spoke for themselves. By mid-1964, nearly 1 in 5 missions into heavily defended targets resulted in aircraft losses. His proposal centered on self-protection jamming pods that would create false targets, generate angle deception, and mask the true position of individual aircraft. Instead of broadcasting omnidirectional noise that screamed "aircraft here," the pods would analyze incoming radar signals, identify their characteristics, and respond with precisely tailored countermeasures. The SA-2's Fansong radar would see phantom aircraft, receive contradictory range information, and lose track of the real target in a cloud of electronic ghosts. The Pentagon's Electronics Warfare Division had rejected the concept twice already. Too complex for field conditions, too much power required for pod-sized systems, insufficient testing. The underlying objection was simpler. If small pods could defeat Soviet radars, why had the Air Force spent a decade developing specialized jamming aircraft? Kozemchak was essentially telling them their entire electronic warfare doctrine was obsolete. He left the Pentagon that afternoon knowing the official answer would be no. But he also knew something the generals didn't. Sylvania had already built a working prototype using company funds, and the test results were remarkable. In laboratory conditions, their experimental pod had defeated simulated Fansong radars with 90% effectiveness. The technology worked. The only question was whether American pilots would die while bureaucrats debated doctrine. 3 weeks later, another F-105 went down near Hanoi. Then 2 more. The Pentagon's casualty reports started using phrases like unsustainable loss rates and tactical reassessment required. Kozemchak received a phone call on September 12th. The Air Force wanted to see his prototype. They wanted to see it immediately. The numbers were killing morale faster than the missiles. By January 1965, Wild Weasel crews, the pilots tasked with suppressing North Vietnamese air defenses, faced mortality rates that made even veteran airmen hesitate. SA-2 guideline missiles were downing American aircraft at rates approaching 80% when fired within optimal parameters. A single SA-2 site could defend a 30-mile radius, and the North Vietnamese were building them faster than intelligence could map them. Captain Jack Donovan flew his 19th mission into Route Pack 6 on February 8, 1965. His F-105D Thunderchief carried Shrike anti-radiation missiles designed to home in on enemy radar emissions, but the doctrine had a fatal flaw. To fire a Shrike, pilots had to fly straight toward the radar site for 12 to 15 seconds, an eternity when SA-2s needed only 8 seconds from launch to impact. Donovan watched 2 aircraft in his flight disappear in white fireballs before he could pickle his own weapons. He landed at Korat with 17 feet of his right wing shredded by proximity-fused shrapnel. The problem wasn't courage or skill. American pilots were attacking the most sophisticated integrated air defense system ever deployed in combat. North Vietnam's Soviet advisors had linked Fansong radars, command centers, and SA-2 batteries into overlapping networks that eliminated blind spots. When EB-66 jamming aircraft supported strikes, the system simply tracked the jamming source, calculated the likely ingress corridor, and positioned missiles accordingly. The North Vietnamese didn't need to see through the jamming. They just needed to know where it was coming from. Wild Weasel crews developed desperate tactics. Some flew at treetop level until the last possible moment, then popped up to fire before diving away. Others tried terrain masking, using mountains and valleys to break radar lock. Nothing worked consistently. The SA-2's Mach 3 speed and 35,000-pound warhead made survival a matter of luck once a missile was airborne. Proximity fuses detonated at 75 yards, creating a fragmenting cloud that could shred aircraft from wingtip to wingtip. The casualty reports reached General Curtis LeMay's desk with increasing frequency. In March 1965, Operation Rolling Thunder intensified bombing campaigns across North Vietnam, and loss rates climbed accordingly. 7 aircraft in 1 week, 12 the next. The Air Force was losing tactical aircraft faster than training commands could produce replacement crews. Each downed pilot represented 18 months of training and $2 million in taxpayer investment. Each loss also handed the North Vietnamese a propaganda victory. Captured American airmen paraded through Hanoi streets, made headlines worldwide. By May, Wild Weasel squadrons were flying with aircrew manning levels at 60%. Pilots rotated through missions on minimal rest, knowing the odds degraded with every sortie. The standoff jamming doctrine that looked elegant in Pentagon briefings was proving catastrophic over Hanoi. EB-66s couldn't penetrate defended airspace, strike packages couldn't survive without jamming support, and the entire tactical bombing campaign risked collapse. Intelligence analysts studying wreckage patterns and mission reports reached an unavoidable conclusion. American aircraft needed jamming protection that moved with them, not equipment that stayed 50 miles away broadcasting their intentions to every radar operator in North Vietnam. The Air Force needed what Kozemchak had been proposing for 8 months, self-protection pods that turned every fighter bomber into its own electronic warfare platform. The question was whether the technology could be developed, tested, and fielded before the casualty lists became politically unbearable. Kozemchak's team at Sylvania's Mountain View facility received the contract on June 3, 1965, with a deadline that made experienced engineers laugh nervously. 9 months to design, build, test, and deliver operational jamming pods capable of defeating Fansong radars in combat conditions. The typical development timeline for military electronic systems ran 3 to 5 years. The Air Force was asking for a miracle, and Kozemchak had exactly 273 days to deliver it. The technical challenges started with power. Self-protection jamming required generating enough electromagnetic energy to overwhelm or deceive radars while fitting inside a pod measuring 14 feet long and 12 inches in diameter. The ALQ-71 prototype, Kozemchak, had demonstrated used commercial components never designed for 9G maneuvers, 100-degree temperature swings, and the vibration environment inside an F-105 flying at Mach 1.2. Every component had to be redesigned for military specifications while maintaining the performance that had impressed Pentagon observers. The engineering team worked in 3 shifts, covering 22 hours daily. Kozemchak's lead RF engineer, Tom Marchetti, spent August testing traveling wave tubes that could generate sufficient jamming power without exceeding the pod's thermal limits. Each tube consumed 1,800 watts and produced enough heat to melt solder joints if cooling systems failed. The pod design incorporated ram air scoops internal ducting, and heat exchangers that had to function across the F-105's entire flight envelope. From sea level to 40,000 feet, from stall speed to supersonic dash. The jamming technique itself required innovation beyond existing electronic warfare doctrine. Instead of broadcasting broadband noise, the ALQ-71 would receive incoming fansong signals, analyze their pulse repetition frequency, and scan pattern, then transmit precisely timed deception pulses. The pod would convince the SA-2 radar that the aircraft was 200 yards left of its actual position, or closing at half its true speed, or descending when it was climbing. The margin for error was measured in microseconds. Transmit the deception pulse too early or too late, and the radar would reject it as spurious noise. By October, the first flight-ready prototype pods arrived at Edwards Air Force Base for testing. They looked utilitarian compared to the sleek lines of fighter aircraft, cylindrical aluminum housings with stubby antennas and cooling vents that gave them the appearance of industrial machinery strapped under wings. Each pod weighed 387 pounds fully loaded, including batteries, transmitters, receivers, and the analog processing units that controlled jamming sequences. The initial ground tests revealed problems Kozemchak's team hadn't anticipated in laboratory conditions. Electrical interference from the F-105's own radar degraded the pod's receiver sensitivity. Engine vibrations at specific RPM ranges caused circuit boards to crack. The RAM air cooling system that worked perfectly in wind tunnel testing created aerodynamic drag that reduced the aircraft's combat radius by 30 miles. Test pilots reported handling changes with pods mounted. The F-105 required additional trim authority and exhibited slight roll coupling at high angles of attack. December brought the first captive carry flights with powered pods. Kozemchak watched from Edwards' control tower as an F-105D thundered down runway 22 with ALQ-71 pods under each wing. The aircraft rotated cleanly and climbed toward the test range where simulated fansong radars waited. For 6 minutes, telemetry showed normal operation. Then both pods went into thermal shutdown simultaneously. The test pilot declared an emergency and returned for landing with 2 400-pound paperweights hanging from his wings. The team had 4 months remaining until the Air Force's deployment deadline. The failure analysis took 3 days and revealed a fundamental design flaw. The RAM air cooling system worked perfectly at high speed and altitude, exactly the conditions used in wind tunnel testing, but during the high G turns and dive profiles that fighter pilots actually flew in combat. Airflow through the cooling ducts decreased by 40%. Internal temperatures spiked above 200 degrees Fahrenheit, triggering automatic shutdowns designed to prevent catastrophic equipment failure. Kozemchak's pods could defeat Soviet radars beautifully, provided the aircraft flew straight and level like a transport plane. Test pilot Major Carl Jensen delivered the news with characteristic bluntness during the January 12th review at Edwards. He'd flown 3 missions with ALQ-71 pods, and 2 had ended with thermal shutdowns during simulated combat maneuvers. The 3rd mission produced intermittent jamming power as internal temperatures fluctuated. Jensen told the assembled engineers that no pilot would trust equipment that quit working precisely when they needed it most, while dodging missiles and pulling maximum G-loads. The traveling wave tubes were the heart of the problem. Marchetti's team had pushed the components to their absolute thermal limits to generate sufficient jamming power within the pod's size constraints. There was no margin for error, no safety buffer for real-world operations. The Air Force's deadline was now 14 weeks away, and Sylvania had pods that worked superbly in conditions that didn't exist in combat. Kozemchak spent 4 days locked in Mountain View's test lab with Marchetti and 3 senior thermal engineers. They ran simulations, built mock-ups, and tested cooling configurations that grew increasingly desperate. Liquid cooling added 60 pounds of weight and required pumps that would fail in combat damage scenarios. Passive heat sinks worked, but required tripling the pod's diameter, making them too large to mount on tactical aircraft. Every solution created new problems, worse than the ones being solved. The breakthrough came from an unexpected source. Junior engineer Patricia Caldwell had been analyzing telemetry from the failed test flights and noticed something the senior engineers had missed. Power consumption peaked during the first 90 seconds of jamming operation, then stabilized at lower levels as the system reached steady-state operation. The thermal shutdowns always occurred during that initial high-power phase. Caldwell proposed a radical solution: reduce peak transmit power by 15% during startup, then gradually increase to full power as cooling systems stabilized. The senior engineers hated it immediately. Lower transmit power meant reduced jamming effectiveness. In laboratory tests, the 15% reduction decreased jamming success rates from 90% to 73%. Kozemchak listened to the arguments for 2 hours before making his decision. Pods that worked 73% of the time were infinitely better than pods that shut down completely. They would implement Caldwell's solution. The redesign required rebuilding the power management circuits in every pod. February became a blur of 18-hour workdays, circuit board modifications, and increasingly tense phone calls from Pentagon procurement officers demanding status updates. The Air Force had already allocated funding for 250 pods based on Sylvania's promised delivery schedule. Aircraft were being modified to carry them. Tactical squadrons were developing employment doctrine. The entire program balanced on whether Kozemchak's team could solve the thermal problem before the Air Force lost patience and canceled the contract. On March 3rd, Major Jensen flew the first test mission with redesigned pods. He put the F-105 through a punishing profile: high G turns, supersonic dashes, simulated SA-2 evasion maneuvers. The pods maintained operation throughout the entire 40-minute flight. Telemetry showed internal temperatures peaking at 187 degrees, well below the shutdown threshold. Jensen's post-flight report contained 2 words: "It works." Working pods solved the engineering problem, but triggered a new crisis that had nothing to do with technology. The Air Force Tactical Air Command wanted immediate deployment to Southeast Asia. Strategic Air Command objected, citing insufficient testing. The Pentagon's Electronic Warfare Division questioned whether self-protection jamming would compromise existing EB-66 standoff operations. Kozemchak found himself defending proven equipment against bureaucratic resistance that grew more determined as deployment approached. The pods had been redesignated ALQ-87 after the thermal redesign, and by April 1966 they were exceeding performance specifications in every measurable category. Test missions at Edwards and Eglin Air Force Base showed consistent jamming effectiveness against simulated Fansong radars. The pods survived 9G maneuvers, operated across the entire flight envelope, and required minimal maintenance between sorties. Major Jensen had flown 23 test missions without a single equipment failure. The technology was ready. The Air Force wasn't. Colonel Richard Browning led the opposition from his Pentagon office. He'd spent 15 years developing the doctrine that specialized electronic warfare aircraft provided better protection than self-jamming pods. Browning argued that ALQ-87 deployment would fracture the integrated jamming approach that coordinated EB-66 support with strike packages. His classified memo to the Chief of Staff called self-protection pods tactically unsound and strategically short-sighted. The memo reached General John McConnell's desk on May 8th, along with Browning's recommendation to cancel the program. Kozemchak received the news through Sylvania's Pentagon liaison. The company had manufactured 127 pods at a cost of $84,000 each. Aircraft modifications were complete. Aircrew training manuals had been written and distributed. The entire program could be terminated with a single signature. He requested a meeting with McConnell and was granted 30 minutes on May 23rd. The presentation Kozemchak delivered that morning contained no charts showing cost savings or production timelines. Instead, he brought casualty statistics. 37 aircraft lost to SA-2 missiles since January. 53 pilots killed or captured. loss rates that would drain tactical air strength within 18 months if they continued. He showed McConnell gun camera footage from test missions, simulated SA-2 sites launching missiles that flew past ALQ-87 equipped aircraft, unable to maintain lock. Then he showed footage from actual combat missions, missiles tracking unarmed aircraft with deadly precision. McConnell asked one question: could the pods be deployed within 90 days? Kozemchak guaranteed it. The meeting lasted 17 minutes. McConnell signed the deployment authorization before Kozemchak left the building. Production ramped immediately. Sylvania's Mountain View facility expanded to 4 shifts running around the clock. Component suppliers were told to triple their manufacturing capacity or lose the contracts. Quality control inspectors checked every circuit board, every traveling wave tube, every connector and cable. A single faulty pod could kill an American pilot and doom the entire program. The first operational pods shipped to Korat Royal Thai Air Force Base on August 12, 1966. The 308th Tactical Fighter Wing received 40 pods and began immediate aircrew training. Pilots were skeptical. Most had seen promising equipment fail under combat conditions, and the ALQ-87 pods looked too small to defeat sophisticated Soviet radars. Maintenance crews were more optimistic. The pods required minimal servicing, could be installed in 20 minutes, and used standard electrical connections. Intelligence reports from North Vietnam showed the opposition was also preparing. Soviet advisors had upgraded Fansong radars with frequency hopping capabilities and improved tracking algorithms. The SA-2 batteries around Hanoi had been reinforced with additional launchers and fire control systems. Both sides understood that the first combat test of ALQ-87 pods would determine whether Kozemchak's 4-year struggle had produced a war-winning technology or an expensive failure. The pods sat in environmentally controlled storage at Korat, while Pentagon planners debated their employment. Colonel Browning's allies in the Electronic Warfare Division insisted on comprehensive operational testing before combat deployment. They wanted 6 months of controlled experiments measuring pod effectiveness against various threat scenarios. They wanted doctrine development, integration studies, and coordination protocols with existing jamming assets. What they really wanted was time for self-protection jamming to fail so standoff doctrine could be vindicated. Kozemchak watched the delay from Mountain View with growing frustration. American pilots were still dying over North Vietnam, while fully operational equipment sat unused 7,000 miles away. The casualty reports continued their grim rhythm. 3 aircraft lost the first week of September, 4 more by mid-month. Each loss represented a pilot who might have survived with ALQ-87 protection. The Pentagon's insistence on additional testing had nothing to do with safety and everything to do with protecting institutional territory. The Air Force had invested heavily in EB-66 electronic warfare aircraft. Entire squadrons existed solely to provide standoff jamming support. Careers had been built managing these programs. Self-protection pods threatened that infrastructure by suggesting it was unnecessary. If individual fighters could jam their way through defended airspace, what was the point of specialized jamming aircraft? Browning and his colleagues understood the implications perfectly. Lieutenant Colonel Robin Olds commanded the 8th Tactical Fighter Wing at Ubon Royal Thai Air Force Base and had no patience for Pentagon politics. He'd flown combat missions in World War II and knew the difference between doctrine that worked and doctrine that killed people. In late November 1966, Olds flew to Korat and personally inspected the stored ALQ-87 pods. He reviewed test data, talked to maintenance crews, and studied employment procedures. Then he sent a classified message directly to Pacific Air Force's headquarters, requesting immediate pod deployment to his wing. The request triggered another Pentagon review. Browning's team produced a 40-page analysis explaining why operational testing remained incomplete. They cited concerns about electromagnetic interference with friendly communications, potential compromise of classified jamming techniques if pods were captured, and the need for coordinated employment doctrine. The analysis recommended a minimum 6-month delay for additional testing and evaluation. General William Maumier commanded 7th Air Force and had authority over all tactical air operations in Southeast Asia. He received both Browning's analysis and Old's deployment request on December 8th. Maumier had been reviewing loss statistics and understood what the numbers meant. At current attrition rates, tactical fighter strength would degrade below mission-capable levels within 8 months. The Air Force was losing the electronic warfare battle, and specialized jamming aircraft weren't stopping the bleeding. Maumier's response bypassed the Pentagon review process entirely. On December 15th, he authorized immediate ALQ-87 deployment to the 8th Tactical Fighter Wing under operational test protocols. The language was carefully chosen. Calling it operational testing satisfied Pentagon requirements while getting pods into combat immediately. Olds would receive 30 pods with authority to employ them against North Vietnamese air defenses as he saw fit. The pods arrived at Ubon on January 4, 1967. Maintenance crews spent 2 days installing them on F-4C Phantom aircraft and running systems checks. Pilots attended rushed briefings on pod operation, primarily what not to do, since the ALQ-87 operated automatically once powered on. The system detected incoming radar signals, analyzed their characteristics, and transmitted appropriate countermeasures without pilot input. It was designed to work while pilots focused on flying and fighting. Intelligence selected the first target with deliberate intent. The Paul Doomer Bridge near Hanoi was defended by the most concentrated SA-2 coverage in North Vietnam. 12 sites with 64 missiles protected the crossing. Previous strikes had lost 6 aircraft in 4 attempts. It was exactly the kind of heavily defended target where ALQ-87 pods would either prove their worth or fail spectacularly. The mission briefing at Ubon began at 0430 hours on March 10, 1967. Colonel Olds laid out the strike package: 16 F-4C Phantoms carrying Mark 82 bombs, 8 equipped with ALQ-87 pods, 8 flying clean as control aircraft. The plan deliberately separated pod-equipped and unequipped flights to measure effectiveness. If the pods worked, the difference in SA-2 engagement results would be unmistakable. If they failed, half the strike package would still have a chance to egress safely using traditional evasion tactics. Captain Mike Nelson drew the lead position in the pod-equipped flight. He'd flown 47 missions over North Vietnam and survived 3 SA-2 near misses through a combination of skill and luck. The briefing officer explained that the ALQ-87 would handle jamming automatically. Nelson just needed to fly the mission profile and trust the equipment. That last part made experienced pilots uncomfortable. Trusting untested gear, while SAMs flew at Mach 3, required faith most combat veterans didn't possess. The strike package launched at 0615 and formed up over the Gulf of Tonkin. Weather was clear, 8-mile visibility, and scattered clouds at 12,000 feet. Perfect conditions for both attackers and defenders. The Fansong radars would have no atmospheric interference, and SA-2 optical tracking would be unimpeded. Nelson checked his ALQ-87 status panel. 4 green lights confirmed the pod was powered and operational. He still didn't believe a 14-foot cylinder could defeat the integrated air defense network protecting Hanoi. The package crossed the coastline at 0641 and immediately lit up radar warning receivers. Multiple Fansong radars locked on, their characteristic warbling tone filling cockpit headsets. SA-2 sites were tracking the formation, calculating firing solutions, waiting for optimal engagement range. This was the moment when EB-66 jamming aircraft would normally begin transmitting, alerting every radar operator within 100 miles that American strikes were inbound. Nelson's flight flew in radio silence with only the ALQ-87 pods operating. The first SA-2 launch came at 0644, 2 missiles from a site northeast of the target. White smoke trails arcing upward against blue sky. Nelson's radar warning receiver showed continuous lock, but the missiles tracked past his flight at 1,000 yards lateral separation. They detonated harmlessly in empty sky. Proximity fuses triggered by phantom targets the ALQ-87 had created. 2 more missiles launched seconds later with identical results. The Fansong radars were seeing Nelson's flight in positions they didn't actually occupy. The pod-equipped flights reached the Paul Kozemchak Bridge at 0647 and rolled into their bombing runs. SA-2 sites launched continuously. 8 missiles in the air simultaneously at peak engagement. Nelson watched them fly past, arc overhead, detonate at wrong altitudes. His radar warning receiver never stopped screaming, but no missile came close to his aircraft. The pods were generating enough deception that SA-2 guidance systems couldn't distinguish real targets from electronic ghosts. The clean flights without pods had different experiences. 3 aircraft took proximity-fused shrapnel damage. 1 F-4C lost hydraulic pressure and diverted to Udorn with battle damage. The pilot reported standard SA-2 engagement, missiles tracking accurately, forced to execute violent evasion maneuvers, pure luck determining survival. The presence or absence of a single pod made the difference between flying through defended airspace untouched and fighting for survival against missiles that knew exactly where you were. Post-strike intelligence analysis counted 19 SA-2 launches against the pod-equipped flights with 0 hits or damage. The unequipped flights faced 11 launches resulting in 1 aircraft damaged and 2 more forced into evasive breaks that prevented weapons delivery. The statistics were definitive. ALQ-87 pods reduced SA-2 effectiveness from near certainty to near impossibility. Kozemchak received the mission results via encrypted message at 1830 hours California time. 4 years of work had just been validated in 11 minutes over Hanoi. The North Vietnamese response came faster than American intelligence anticipated. Within 72 hours of the Paul Kozemchak Bridge strike, Fansong radar operators began reporting systematic tracking failures. Soviet technical advisors arrived in Hanoi on March 15th to investigate what they initially assumed was equipment malfunction. The SA-2 system had been firing missiles at targets that radar showed clearly, yet the missiles consistently missed by margins, suggesting fundamental guidance problems rather than pilot evasion. Russian engineers spent a week analyzing radar recordings and missile telemetry. The data revealed something unprecedented in air defense operations. Fansong radars were receiving return signals from American aircraft, calculating proper tracking solutions, and guiding SA-2 missiles to intercept. But the targets weren't where the radars indicated they should be. The Americans had deployed jamming technology that created convincing false targets while masking actual aircraft positions with extraordinary precision. The Soviet analysis reached Moscow by March 28th with an assessment that shocked air defense planners. The Americans had achieved tactical electronic warfare capability that Soviet systems couldn't counter with existing technology. Fansong radars operated on fixed frequencies that made them vulnerable to precisely tuned deception jamming. The SA-2's terminal guidance relied on continuous radar tracking, which the American pods disrupted at the exact moment missiles needed accurate target data. The assessment concluded that SA-2 effectiveness had been reduced by approximately 70% against pod-equipped aircraft. North Vietnamese air defense commanders faced an immediate tactical crisis. The SA-2 network that had dominated American air operations for 2 years was suddenly unreliable. Missile crews were launching based on solid radar tracks, only to watch weapons detonate harmlessly as targets maneuvered away. Some sites exhausted entire missile inventories during single engagements without scoring hits. Battery commanders began questioning whether to launch at all, knowing each missile represented substantial financial and logistical investment. American intelligence monitored the disruption through signals intercepts and pilot debriefings. By April 1967, ALQ-87 pods had been deployed across tactical fighter wings operating over North Vietnam. The 388th Tactical Fighter Wing reported flying 214 sorties into heavily defended targets with pod-equipped aircraft sustaining 0 SA-2 damage. The 8th Tactical Fighter Wing logged similar results. Aircraft without pods continued experiencing normal loss rates, but pod-equipped flights operated with near impunity against missile defenses that had previously made North Vietnamese airspace lethal. Production at Sylvania's Mountain View facility accelerated to meet demand. The Air Force wanted every tactical aircraft equipped with pods immediately. Orders increased from the original 250 units to 800, then to 1,200, as success in combat operations became undeniable. Engineers worked in round-the-clock shifts, manufacturing pods that were being installed on aircraft and deployed to Southeast Asia within days of completion. The Pentagon's Electronic Warfare Division quietly abandoned opposition to self-protection jamming. Colonel Browning requested reassignment to non-operational duties in June 1967. The doctrine that specialized jamming aircraft provided superior protection died without formal announcement. It simply stopped appearing in tactical planning documents. EB-66 aircraft continued flying missions, but their role shifted from essential protection to supplementary support. Soviet air defense forces attempted countermeasures throughout 1967 and 1968. They modified fan-song radars with frequency diversity, improved tracking algorithms, and enhanced discrimination circuits designed to reject false targets. Nothing worked consistently. The ALQ-87's ability to analyze incoming signals and generate precisely tailored deception proved more adaptable than Soviet engineers could counter. Each modification produced brief improvements, followed by renewed American jamming effectiveness as pods were updated with new countermeasure techniques. By December 1967, SA-2 sites around Hanoi had shifted tactics entirely. Instead of relying on radar guidance, they began firing missiles in barrage patterns at suspected aircraft positions, hoping proximity fuses would achieve hits through volume of fire rather than precision tracking. It was an admission that electronic warfare dominance had shifted decisively to the Americans. Kozemchak's pods had accomplished what no amount of additional bombing or tactical innovation had achieved. They'd neutralized North Vietnam's most effective air defense weapon. The ALQ-87's impact extended far beyond North Vietnam's defeat in electronic warfare. By 1970, every major air force worldwide had begun developing self-protection jamming systems for tactical aircraft. The doctrine that Kozemchak had fought Pentagon bureaucrats to validate became the foundational principle of modern aerial combat. Aircraft must carry their own electronic countermeasures rather than depending on standoff support. The pods that began as a desperate solution to unsustainable loss rates transformed into standard equipment that no combat aircraft would deploy without. Kozemchak received the Air Force Exceptional Civilian Service Award in 1969, though the citation couldn't acknowledge the classified details that made his achievement significant. The ceremony at the Pentagon lasted 12 minutes. General McConnell presented the medal and mentioned that Kozemchak's contributions had saved American lives. The actual number remained classified, but post-war analysis estimated the ALQ-87 prevented between 180 and 240 aircraft losses over North Vietnam. At 1.3 crew members per aircraft, the pods had saved roughly 300 American lives while enabling strike missions that would have been suicidal without electronic protection. The technology evolved rapidly through successive generations. ALQ-87 pods gave way to ALQ-99, then ALQ-131, each iteration adding capability and reducing size. By the 1980s, self-protection jamming systems were being integrated directly into aircraft avionics rather than carried in external pods. The F-15 Eagle incorporated internal jamming equipment as standard. The F-16 Fighting Falcon used modular pods that could be updated with new countermeasure techniques without redesigning the aircraft. Stealth technology reduced radar signatures, but even stealth aircraft carried jamming systems as final defensive layers. Soviet and later Russian air forces invested billions attempting to regain the electronic warfare advantage they lost over Hanoi. They developed frequency-agile radars, home-on-jam missiles, and multi-static radar networks designed to defeat self-protection jamming. American responses matched every innovation with improved countermeasures. The electronic warfare competition that began with Kozemchak's pods continued through decades of Cold War tension and beyond. Modern combat aircraft carry jamming systems weighing a fraction of the original ALQ-87 while generating exponentially more sophisticated countermeasures. Digital radio frequency memory technology allows systems to record incoming radar signals, modify them, and retransmit deception pulses with microsecond precision. Active electronically scanned array radars can jam enemy systems while simultaneously tracking targets. The fundamental principle remains unchanged from 1967. Make the enemy's sensors see what you want them to see, rather than what's actually there. Kozemchak retired from Sylvania in 1982, having spent 18 years refining the technology he'd pioneered. He never spoke publicly about the Pentagon battles, the thermal shutdown crisis, or the pressure of developing life-saving equipment while pilots died waiting for it. The few interviews he gave focused on engineering challenges rather than personal vindication. When asked about the resistance he'd faced, Kozemchak noted that institutional skepticism served a purpose. It forced rigorous testing that ultimately produced better equipment. He died in 1994 at age 68, having witnessed his emergency solution become permanent doctrine. The obituary in Aviation Week mentioned his role developing electronic warfare systems, but couldn't detail the specifics due to lingering classification restrictions. Former colleagues who'd worked those desperate shifts in Mountain View knew what the technical language meant. The pods that looked like industrial machinery strapped under fighter wings had rewritten the rules of aerial combat as fundamentally as radar itself had done 30 years earlier. Every tactical aircraft flying combat missions today carries descendants of technology Kozemchak defended in Pentagon briefings, while generals dismissed it as impossible. The principle he established, that individual aircraft must protect themselves electronically, has proven so fundamental that modern air forces cannot conceive of operations without it. His legacy flies on every mission, invisible but essential, exactly as he'd intended.